Okay, perfect. So you were very right that in my presentation, I would focus actually on the risks or maybe the wrong expectations related to aggregations and their performance consequences. And my focus today will be particularly on cost, because this is what we looked at, and cost efficiency, what we looked at in these previous studies. So I really think, and I mean, you plotted the definition. I really think we have to start and discuss initially our mental model of what an aggregation actually is. And so I drew this graph here, and I think when people talk or think about aggregation, consolidation, or whatever, what they imagine or the vision of aggregation is typically the thing that I drew here on the left. So you have small, maybe one larger provider, and they merge together, and then there is this one big utility. So this is typically the vision, or also much of the empirical evidence that is presented in favor of aggregation and that you can reap large cost efficiency gains is actually based on comparisons like this. So you would take a big capital city maybe and say, okay, if we just put together enough small utilities, towns, and they reach a similar volume like the capital city, they should have the same cost efficiency. I think this is a very unrealistic picture of what really happens in aggregations. So the reality, and this is also what we saw when we looked at aggregations that happened in the Danube region, and also some worldwide examples, is actually rather the picture on the right. So what happens is that you put a holding company or some of the large systems takes charge and is leading this aggregated utility. And but the individual systems still exist. So we still have the towns and the systems in the different municipalities, and these systems are not integrated in the sense that they're physically interconnected. So I think really a better description or mental model of what happens in aggregations is the picture on the right. So this should be driving actually how you think about aggregations and what they will change. Of course, as a researcher, very early on, you go to the literature and look what has been published on the subject. So what you will see if you review the literature, which is really vast, large parts of the empirical literature are based on cross-sectional variation. So people are comparing small systems with large systems, sometimes more simply comparing cost averages, sometimes more complicated with econometric techniques and estimations of economies of scale. But in the end, it is always a comparison of small and large utilities. The recommendations and much which goes into policy is also based on these measured economies of scale, which assume actually, and this is also related to what I said here, if decreasing Ray average cost. So actually, what they measure is, or they look at the situation in which you increase the different outputs of a utility in the same proportions. So this is maybe not a very realistic view of what happens in aggregations in reality already. And I plotted here some descriptive statistics from the data, from IBNet data. And this is similar to what most of these cross-sectional comparisons are showing. So I cut the utilities into different sizes, and the larger the utilities, you see decreasing cost. Yeah, so the median in these box plots is clearly decreasing, and I mean the differences are really sizable. But what you should already see here is actually the variation is quite big. So it is not sure that you will by aggregating just jump from the median to the next median and down the road, but actually there is no guarantee that you will not end up with a higher or very little to no cost savings by aggregate. So there are very few studies actually who look differently at the topic beyond just comparing small and large utilities. And so if you look at these, and I mean, those are also, if you want, quantitative case studies, but I think there are some regularities in these other studies which actually track how the performance of utilities changes before and after aggregations. So what you see there is actually they are much more cautious and nuanced in the results they find. Some of the observations are from the paper by Urakami and Parker, is that particularly for large urban utilities, the performance deteriorates in the wake of aggregations. So by losing density or taking up a lot of not well-functioning utilities, actually their performance is deteriorating. So economies of scale, those utilities growing larger, does not seem to be the driving force for performance. More qualitative evidence from a study from Romania, if I remember correctly, is that in interviews, the large utilities and urban utilities, they are very unhappy if they're aggregated with the rural utilities. Maria labeled it cherry picking, but to some extent, actually, it also shows that you might have a well-functioning urban utility, and there is the risk that you burden them actually with a lot of not well-functioning rural utilities. So there is the risk actually that through aggregating you create something and you destroy a well-functioning system that at least you had in this large utility before. And from our own study, actually, we also find that particularly utilities which have to serve lots of towns, large aggregated utilities, they seem to exhibit some cost disadvantages. So I'm going to show you from our results just 3 reasons or things that you should worry about when you try to design aggregations, what can fail. So here I plotted the 3 output variables that we looked at. So the volume is on top, the number of customers is in the middle, and below you find the number of towns or systems that they serve. And in many cases, so this is just for the utilities before they were aggregated. For many cases, you find that those aggregated utilities were already very big before the aggregation. So you might worry about some diseconomies of scale already before the aggregation. What we see, and this is, I think, related to what Urakami and Parker find, there is a loss of density typically involved for many utilities who aggregate and pick up small and smaller rural utilities. So here I plotted on the left the density, so the number of customers per served town. 0 is before the aggregation and 1 is after the aggregation. And we see the box plot is really decreasing, so density is going down through the aggregations, at least the ones that we looked up into in our example. And the last one here, so I mean, this is descriptive statistics, but if we look at which utilities exhibit the lowest unit costs, I mean, it is large utilities, those that serve a large volume of water. But we also see, and if you look here, it is those on the right side which serve only a single or very few systems. As soon as actually you start to increase the number of systems, so how many cities are connected, how many towns are connected, you see actually that their average unit costs is going up. So I mean, this can be due to technological reasons and more difficulty to deliver water in rural areas. But actually what we found, and the qualitative evidence from the aggregation studies for the World Bank also show that actually there are some organizational and governance problems involved in very large utilities and in the aggregation process. So I'm going to stop here. If you ask the question, because I changed my mind on this subject quite a bit through the studies and looking at what happens in aggregations, whether policy should push for aggregations, whether this is a road and a policy that we should pursue. I really think it depends, and we should look a bit more closely at what we are actually doing. So the initial situation is important, how the structure is before the aggregation, and the way you aggregate actually, how and which systems you put together in the aggregated utility. And here I repeat a bit for the factors that I already mentioned before. So you should worry about that some firms are already very large from the beginning. The loss of economies of density might also be detrimental to cost efficiency. And the governance and organizational questions actually might relate to the question how, because Maria showed you can do very small scale aggregations, only 2 municipalities or whole regions together. Actually, I mean, by this choice, you decide how fragmented or how divided is the ownership in this new big utility. How are the decision processes? How are assets divided? So you create actually very complicated systems through this, where there are many stakeholders, many actors, maybe with very different interests. So this is really something that you should consider at the planning stage. Something also that was mentioned, the upward wage harmonization. We really see this in the data. So we see that that labor cost, which is really a large share of operational cost, does not slow down or even pick up through the aggregations. So the question is, where would we expect the cost savings from aggregations? I mean, shared purchase of materials and stuff, we see some improvement there. But if labor costs are not going down per served volume, actually the potential for cost savings is very small from the start. So my recommendation here, and I'm going to stop, is that you should take some time and really put a lot of effort and thinking into the design stage of the aggregations before proceeding with the actual process. Thank you.